Okay, our second index law tells us that if we have two numbers which are exactly the same, so let's use 3 and 3, and they have different powers, then to get the answer, we can just subtract those powers. So just like up here we had a divided by a, here we've got 3 divided by 3. And so what we can do is we can subtract the powers. So we're going to subtract 5 from 8. So we'll go 3 to the power of 8 minus 5, and then that will equal 3 to the 3. Now the reason we can do this, if we write these out in expanded form, so first of all, if we take this one here, that really is like 3 times 3 times 3, and we'll do that 8 times. 1, 2, 3, 4, 5, 6, 7, 8. And 3 to the 5 would be 5 lots of 3 all multiplied together. There we go. Now, another way of writing division problems, if we think about this section here, another way of writing that would be a to the m over a to the n. So fractions are just division problems. So if we were to write this here as a fraction in expanded form, it would look like this. We would have 8 lots of 3 all multiplied together, and then we'd have 5 lots of 3 all multiplied together on the bottom. So this is 3 to the 8 over 3 to the 5. Now we know that if we have any number divided by itself, it just equals 1. So if we had 2 divided by 2, that equals 1. 10 divided by 10, that equals 1. If we had even something really crazy like 2.468 divided by itself, that equals 1. So what we have in our fraction here is a whole bunch of numbers divided by themselves. So we can cancel them out. So 3 divided by 3 is just 1. So it's not that they disappear, but because those two numbers together are only worth 1, they're not going to change the value of our answer. Because if we're multiplying something by 1, it just stays the same. Like 5 times 1 is 5, 100 times 1 is 100. And so having these two 3's here, they don't change the value of our answer and just clutter up the space. So we can get rid of them. And we can keep on doing that. So this 3 would cancel with this one, that would cancel with that, that would cancel with that, that would cancel with that. And so what are we left with? We're left with just 3 lots of 3 multiplied together here. And so we can abbreviate that to 3 to the power of 3. And that's how we get to our answer. So let's have a look at another example together. Let's do 4 to the power of 7 divided by 4 to the power of 2. So we know from our rule that if we've got the same base number, then all we need to do is subtract the powers. So 7 take 2, and so that will equal 4 to the 5. Let's have a look at an example with algebra base numbers. So if we had m to the 5 divided by m squared, then same thing, even though we don't know what m is, we know that it's the same number, so we can use our second law. So we'll have m in our answer, and then to sort out the powers, we just need to subtract those, and we'll get m to the power of 3. Okay, let's have a look at a slightly trickier one, which has got some coefficients in it. So let's have a look here at 6a to the 5 over 3a to the 4. So in this example, we've just got an extra step because we have to sort out the numbers there first. Now, remember that fractions, so this line here, just means divide. That's what that is. So we can read this as 6 divided by 3. So 6 divided by 3 is just 2. When it comes to our a's, again, remember that this just means a to the 5 divided by a to the 4, which is just like what we were doing up here before. So it's the same process. And so with our a's, we're going to write a in our answer because we've got the same base number, and then we just subtract the powers. So 5 take 4 is 1. Now in algebra, we don't really like writing ones, so we're going to simplify that just to 2a, and that means the same thing. Okay, in the next one, it doesn't quite divide as nicely for us. So let's have a look at what happens here. We're going to have 12 a to the 6 over, let's go 8a to the 2. So even though this is a division problem, if we try and read it as a division problem and say 12 divided by 8, that doesn't really work. It doesn't give us a nice answer. So it is still division, but we need to think about it from a different point of view. We need to think about it in terms of simplifying these numbers. And we simplify by finding a number that fits into both of them. So we're trying to find a number that will go into 8 and 12. Now, sometimes there are a few numbers that will fit into it, and it's really good to try and find the highest number that you can. But if you can't, just pick a number that you know definitely goes into them, and then you can keep applying the process to get to the answer. So in this example, 4 goes into both of these numbers, but let's say you didn't think of 4 and all you could think of was 2. So if we divide both of these by 2, we divide 12 by 2 and we divide 8 by 2. So 8 divided by 2 is 4, 12 divided by 2 is 6. Then all you need to do is check your answers again. And if we check 6 and 4, we say the same thing. What fits into both of them? Oh yeah, we could divide that by 2 again. Divide 6 by 2. So 4 divided by 2 is 2. 6 divided by 2 is 3. And then if we check our answers now, nothing else will go into both of these. There's nothing that will go into both 3 and 2 apart from 1. And we can't really use 1 because it won't help us to simplify. We'll end up at the same answer again. If we go 3 divided by 1, we still have 3. And if we go 2 divided by 1, we still have 2. So that's the final numbers we're going to finish with. On the other side of our fraction here, we've got the a's. And remember the a's again are just division as well. So it's the same base number, and so we can just subtract those powers. So let's just clean up our work a bit here. So we're going to come across. We need to keep the top and bottom row of our fraction, but we've simplified the numbers to 3 and 2, and now we need to simplify the a's. So if we've got a to the 6, let's write it over here, a to the 6 divided by a to the 2, then we know that because these are both the same base number, we can just subtract the powers, and so we end up with a to the 4. So in our answer, we're going to take that a to the 4 and put it on the top here, a to the 4. And so that is our actual final answer. We can get rid of that part of our fraction line. We still need the fraction line there. I was just going to make it shorter. So we end up with 3a to the 4 over 2. Now, if you weren't quite sure about how I knew to put that on the top there, like why did it go on the top and not on the bottom, you just need to remember with the a's, so if we look at this red box, what we really have is a times itself 6 times over a times itself 2 times. And if we go through that process of cancelling them out again, we end up with 4 a's left on the top row. And so that's where that a came from on the top row. And that's why there was none left on the bottom row. There was no a's left in there.